So good morning students, I hope you all are fine and enjoying the videos shared by different subject teachers and continue your study during this period when the whole country is locked down. So today we are going to solve some questions based on real numbers chapter 1 class 10 on the different topic which we already discussed in our first 3 videos, that is Euclid division algorithm, SCF and LCM of two numbers, how to prove any number is irrational, how to find the LCM and SCF of different numbers, and the decimal expansion of the rational number. So let's start the first question of today's lecture, which is find the SCF of 867 and 255 using Euclid division algorithm. So let's start the solution of this question. So when we divide this 867 by 255, it will go 3 times and give 102 as a remainder, which I already discussed this in my lecture, how to do the division process. This is nothing but the division algorithm where the dividend is equal to divisor into quotient plus remainder. So now in the second step we are going to divide this divisor by the remainder 2 times, so 204, and this will give 51 as a remainder. So when we divide this 102 by 51, it will go 2 times and give 0 as a remainder. So this 51 will be the SCF of 867 and 255. So I already told you that this method is used to find the SCF of two big numbers. So 867 and 255. When we are going to divide these two numbers using the factorization method, it will be very difficult for us because we are not knowing this 867 is divisible by which number. When we start thinking, it takes some time, maybe the time which was taken here, twice, thrice of that time. So we are using Euclid division algorithm to find the SCF of these two numbers, which is looking very complicated, but when we start solving these two numbers, we get the SCF in only 3 steps. So now see, let's do the second question. So the second question is show that any positive odd integer is of the form 4q plus 1 and 4q plus 3. Now for such type of question, the solution is hidden in the question itself. Here in solution we will choose a number where the divisor is 4, because here it is 4. So let's take A is equal to 4q plus r. 4q plus r, where r greater than equal to 0 and less than 4. That is, r is always greater than equal to 0 and less than the divisor. Now, a is equal to 4q when r is equal to 0. A is equal to 4q plus 1. R is equal to 1. A is equal to 4q plus 2. R is equal to 2. And A is equal to 4q plus 3 when R is equal to 3. Now, the R start from 0 and goes till 3 can't be 4. This was in the principle of this Euclid division lemma. Now, if we see the first number, A is equal to 4q. Any number, any natural number starting from 1 till infinite, if we multiply it by 4, it will always give us an even number. 4 into 1, 4, 4 into 2, 8, 4 into 3, 12, 4 into 4, 16, and so on. We can clearly see that this 4q is an even number. 4q is an even number. Now, when we add a digit 1 in any even number, it will give us the next odd number. So, 4q plus 1 will be odd. And we know that if we add 2 in any odd number, this will give us the next odd number. So 4q plus 1 plus 2, that is 4q plus 3. So 4q plus 1 and 4q plus 3 will be odd numbers. In this manner, we can show any positive integer is of the form 4q plus 1 and 4q plus 3. Any positive odd integers is of the form 4q plus 1 and 4q plus 3. This will help you for solving some other similar type of questions. Now the next question, that is question number 3 for today, is can two natural numbers have 15 as their SCF and 175 as their LCM? We also have to give the reason behind it, whether it is yes or no. If it is yes, why it is yes. If it is no, why it is no. So let's see the third question. The third question is, can two natural numbers have 15 as their SCF and 175 as their LCM? Give reasons. Now, for such question, it's a very short answer at question, but it was also the part of previous year board paper. So, for such questions, the answer is no. Now, why the answer is no? Because the SCF is always the factor of the LCM. SCF is always the factor of LCM. For this we can take one question. Let 25 and 80. So SCF is equal to 5. How? 25 is equal to 5 into 5. 80 is equal to 2 into 2 into 2 into 2 into 5. So this is SCF. And LCM is 5 is 25, 16, 400. If we see this 400 is, this 5 is the factor of this 400. So here the answer is no, because the SCF is always the factor of LCM. And here 15 can't totally divide this 175. 15, when we divide this 175 by 15, it will not give the remainder as 0. So answer is no, because the SCF is always the factor of LCM, which is not here in this case. So it's a very short answer type question. Now the next question is, find the largest number which on dividing 1251, 9377 and 15628 leaves remainder as 1, 2 and 3 respectively. Now such questions are not in your NCERT book, but if you go through R.S. Agarwal and R.D. Sharma, you will find such type of questions. And also this question was the part of last year board examination. So let's see how to solve this question. In such type of questions, before starting, we will subtract 1 from 1251, 2 from 9377 and 3 from 15628. Whatever the number will we get after subtracting, we will find the SCF of those numbers. Why SCF? Because here it is said largest number. So 1251 minus 1 will give us 1250. 9377 minus 2 will give us 9375, and 15628 minus 3 will give us 15625. So 12,050, this can be written 2 into 5 into 5 into 5 into 5, and this 9375, this can be written 3 into 5 into 5 into 5 into 5 into 5, and this 15,625 can be written 5 into 5 into 5 into 5 into 5 into 5. Now the SCF, we see this is first, this is second, this is third, and this is fourth. So HCF of 1250, 9,375 and 15,625 is 625. I hope you all will understand the concept, and you will be able to solve similar questions from R.S. Agarwal and R.D. Sharma. Now the next question which we are going to solve for today is find a rational number between root 2 and root 7. The next question is find a rational number between root 2 and root 7. So the question is, a rational number means any single rational number. So rational numbers are of two types, terminating and repeating, non-terminating. So it's better to choose a terminating type number which is in between root 2. Now how we will come to know the value of root 2? So we take something lump sum. It is 1.414, but if you are not knowing, let's take 1.5, something like this, and root 7 is less than root 9, that is 3. So any number between 1.5 and 2.5, any number. So I will write 2 is the answer. 2 is the answer because root 2 is 1.414 and root 7 is, this is 2.64. So any number between root 2 and root 7, 2 is the answer, which is, again, it's a very short answer type question. Now the last question is after how many decimal places will 27 upon 2 पे power 3, 5 पे power 4, 3 पे power 2 will terminate. Again, a very simple trick is behind such type of questions, and the trick is in the denominator, if it is not given in factorization form, then first we'll find the factor of the denominator, we express in such form, and then we will see the maximum power on any number, whatever is the maximum power. So here the maximum power is on 5. So this number will terminate after 4 decimal places. So solution, here maximum power is on 5, that is 4. So the given number will terminate after 4 decimal places. I hope you understand whatever are the today's question, and thank you for today.